You know, every single time you install an app or run an update, you're placing a bet. It's a bet that the software you're getting is exactly what it claims to be from who it claims to be from. But in today's digital world, with software built on more software, how can you really be sure? Okay, let's dive into this. We're going to explore a project called Sigstore that's trying to solve this very problem, forging trust right at the foundation of our entire software world. So, just how big is this bet that we're all making every day? Well, get this number in your head: 97%. That's the estimated slice of commercial applications today that contain open source code. It's an absolutely staggering figure. It really shows you just how interconnected and, frankly, how dependent we are on code written by thousands of people all over the globe.
And this brings us to this really important idea of a software supply chain. The best way to think about it is this. Modern software isn't really built from scratch anymore. It's assembled, kind of like a skyscraper made from prefabricated blocks. And this is fantastic for moving fast and innovating, right? But it also means that you inherit the entire history and all the potential problems of every single one of those blocks you use. And that dependency, that inherited risk, brings us right to our first section, the invisible crisis.
Now, this crisis is not some abstract theory. It is happening right now. What's so interesting about these examples is how they show the different ways trust can be completely weaponized. You had SolarWinds, where attackers poisoned a software update from a vendor everyone trusted. Then there was Log4j, where a flaw in one tiny buried component caused a global security firestorm. And then you have stuff like typo squatting, which is happening all the time, where attackers just trick developers into using malicious code that simply looks like the real thing. It's three different tactics, but they all share one common theme: they exploit our trust. And here's the core of the problem. It highlights this fundamental, kind of unfair imbalance. The attackers, they just need to find one weak link in that entire global chain. Just one stolen password, one unpatched library. But us, the defenders, we have to secure everything, all the time. It really makes these kinds of attacks a matter of when, not if. So you might be thinking, if this problem is so big and so obvious, why haven't we solved it already? Well, that's a great question. And it takes us to our second section, where we look at why the old shield we had completely broke. For the longest time, the main tool we had for this was something called Pretty Good Privacy. You've probably heard of it, PGP. And the idea was solid. Developers could digitally sign their code with a secret key, proving it really came from them. But here was the huge catch. In practice, using PGP was an absolute nightmare. This quote from a super famous paper all the way back in 1999 called it fundamentally unusable for non-experts. And honestly, that problem never really went away. The cryptography behind it was brilliant, it was strong, but the user experience, it was just way too complex for the average person to get right. And the lesson we learned from PGP's failure is absolutely crucial. For security to work, it has to be the easy thing to do. It has to be the path of least resistance. If your security tool makes a developer's life harder, they're just not going to use it, period. And this is exactly where our story takes a really exciting turn. Section 3 introduces a totally new way of thinking, an approach people started calling "let's encrypt for code." See, Sigstore's big game-changing idea was to flip the entire problem on its head. Instead of forcing every developer to become a cryptography expert managing all these complex long-term keys, it shifts the focus to something developers already do all day, every day, proving their identity, just logging into their GitHub or Google account. And the way it works is through this team of 3 core components, and each one has a very specific job. You've got Cosign, which is the super simple, user-friendly tool you actually use. Then there's Fulcio, which acts like an automated digital notary that hands out temporary certificates. And finally, Rekor, which is a public, tamper-proof log that records every single signature for the whole world to see and verify. This table just drives the point home so perfectly. Just look at the difference here. Key management? It goes from being this manual, error-prone headache to being completely automated and keyless. Identity? We go from that clunky, manual web of trust to just using the same secure logins we use every day. And for the first time ever, we get a public, auditable log of every single signing event. It is a completely different world. Okay, so this all might sound a little bit like magic, right? A keyless system that uses cryptography. So how does it actually work? Well, let's pull back the curtain. In Section 4, the cryptographic dance. Yeah, this is the million-dollar question, isn't it? How can you possibly have cryptographic signing if you're telling me it's keyless? It sounds like a contradiction. Well, the answer is this incredibly clever bit of, let's call it, cryptographic sleight of hand. It's not that there are no keys involved, it's that you, the developer, never have to manage them. For every single signature, a brand new key pair is generated in the background, it's used one time, and then it's immediately destroyed. Think of it like a self-destructing safe deposit key. You use it for one single transaction and poof, it's gone. There's nothing to steal, there's nothing to lose. So for a developer, this whole process becomes unbelievably simple. Step 1, you prove who you are just by logging in with your Google or GitHub account. This gives you a temporary digital passport. Step 2, you show that passport to Fulcio, our digital notary, and it instantly issues you a very short-lived certificate. And then, step 3, the proof of that signature gets permanently stamped into Rekor's public log. And that last step with Rekor is absolutely critical. You might be asking, wait, if the certificate is only valid for, like, 10 minutes, how can I trust a signature years from now? That's where Rekor is the hero of the story. You can think of it as this indestructible public records book. It provides that permanent, undeniable proof that the signing event happened at a specific time, while that temporary certificate was still valid. It's the whole key to long-term trust. So, this isn't just some clever idea on a whiteboard. It is already having a massive impact out there in the real world. And that brings us to our final section, forging a secure future. And the adoption has just been incredible. I mean, we are not talking about small projects here. We're talking about the absolute foundations of modern software. Kubernetes, the Python language itself, NPM, which is the heart of the JavaScript ecosystem. When these giants adopt Sigstore, it creates this powerful ripple effect, raising the security bar for absolutely everyone. What this technology really enables at the end of the day is a new kind of powerful automated security. Now, an organization can create a concrete, machine-enforceable rule inside their systems that says something like, we will only run software that has been digitally signed by our official build team. This takes security from being a manual checklist to being actual enforceable code. And the vision doesn't even stop with source code. The same principles are now being used to tackle the next big challenge, securing AI models, making sure the model you're using hasn't been tampered with. The project is even looking ahead, preparing for a post-quantum future to make sure this system of trust we're building is going to last for decades. So when you boil it all down, what Sigstore really created wasn't just a better tool for signing code. It created a free, open, and universal standard for something called digital provenance, a reliable, trustworthy way to know where any digital artifact, any piece of software, truly came from. And that leaves us with this really fascinating thought to end on. We now have this incredible, easy-to-use tool to verify the origin of all of our software. So the real question is, what comes next? What else will we, and what else should we start to verify?